And the final 3 is not a 3 at all. when we asked Kunal to deliver a 3, he delivered a 5. So we can't, we can't be upset with Kunal. But hopefully that maybe 5 is a sign of the future of where we're headed, right? So you can tell us about 5 times QoE.
Thanks so much, David. So I think everybody here is familiar with the Indian telecom market by now. The numbers are very large, and so they sound very impressive, right? Over 800 million mobile broadband subscribers, out of which, all but 100 million of them are actually, on mobile networks. And therefore, there's this huge dependency to get wireless networks working properly. And if you see, what's really happened since the launch of 4G in India, the country's become the #1 consumer of YouTube videos in the world. Everybody watches cricket almost exclusively on their mobile devices. And a lot of this consumption is really starting to clog networks significantly. So if you look at the average consumption per user per month on mobile networks from a data perspective, it's today around 19 gigs per user per month. That's really the highest in the world. I mean, that's the type of consumption that one would expect to see on fixed line networks, and you're now seeing that happening purely over 4G networks across the country. And this is not an urban average. This is urban plus rural and everything sort of put together. So it was in this environment that we basically said that, look, with the increasing reliance on mobile networks to deliver higher speeds on data, higher levels of actual capacity, and with the coming of 5G, which is now launched in India as well, and we've heard about earlier, we believe that the traditional network deployment models are just not going to work. And by traditional network deployment models, it means you have a telco, they work with a standard OEM on a proprietary monolithic system that gets deployed on a traditional tower, typically a macro site, and that's really how the bulk of networks run today in India. But moving ahead, and our experience in being India's largest small cell host really pushed us in this direction, was we saw the push towards heterogeneous networks, and we also saw the need to get data closer to end customers and provide denser solutions from a network density and capacity perspective. And we always had this vision that we knew we would move towards active infrastructure sharing and really towards the virtualization of the RAN. And that's where the partnership with TIP really came into focus. And thanks to David and his team for helping to move us in this direction. So we essentially, about 3 or 4 years ago, said that, look, if we're going to try and build a HetNet-based solution, which is a completely shared end-to-end, third-party neutral RAN network, let's do it in one of the most difficult places that we could possibly find in India to make that happen. And that's how the idea of Mumbai Central Station actually came along. So for those who are not familiar with the Mumbai local railway system, it's one of the densest commuter rail systems in the world. There are 400 route kilometers worth of track. There's 2,813 train services that operate on a daily basis. More than 8 million passengers on weekdays traverse the entire Mumbai local railway system. The population in Mumbai is basically the entire population of Australia. So you can kind of get a sense of the type of scale that we're looking at. And Mumbai Central is one of the stations which has both the Mumbai local commuter trains running through it, as well as is a terminus for intercity and interstate trains as well. And that's why it was one of those areas where we felt that, look, if we can crack the solution here, if we can meet this challenge, then we can do it anywhere in India, maybe anywhere in the world. So when we started out looking at how do we solve this problem, we decided to design an entire shared RAN in partnership with Airtel, Vodafone, Nokia as our network provider, and several other partners. And we partnered up with the Indian Railway System and their telecom arm called RailTel. And really, with the perspective of being that today, the stations across the entire network are primarily served by macro sites from the outside. So Mumbai Central will have, for each of the major telecom operators, anywhere between 5 to 7 macro sites surrounding that area, serving that station. Inter-site distances, as in inter-macro site distances in India, particularly in cities, are very, very small. You're talking about less than 250 meters sometimes between macro sites. And each of these macro sites is completely full. So you're talking about utilization levels upwards of 75 to 80% on the 4G layer serving Mumbai Central Station. So we said that we need to deploy a solution on the platforms, on the tracks inside the station. But the challenge is during the peak hours, you have 65,000 people who travel through the station during the morning peak and the evening peak. And every time a train arrives, there's 1,000 to 1,200 people on that train who are handing in from the surrounding macros into the station. And if you've got two trains coming in opposite directions, you're talking about 2,000 to 2,500 people that are handing over simultaneously, potentially. So we had to build an extremely robust system that would be able to handle not only the throughputs and the capacity, but be able to handle the signaling traffic as well as this huge amount of load that gets put on the system with the people waiting at the station and all the people handing in and handing out at any given point in time. And all of this hand in and hand out happens within a minute. So you've got a train arriving, it stops, so it arrives for 30 seconds, stops for 30 seconds, and then basically leaves the station as well. So the pre-statistics in terms of what was the user experience at the station for users during the peak hours was generally between 2 to, in one of the locations for one of the operators, 7.5 Mbps, in another location for the other operator, 6 Mbps. But post the deployment of our solution, we were able to increase that 5x across both the operators on average. And you can see peak period, and this is busy hour, peak period average speeds reaching as high as 30 Mbps. And the ability to handle all of those handovers, and the KPIs overall that we were able to meet, match the gold standards of the telecom operators' own surrounding networks. Not only were we able to handle this traffic and carry today, as of today, we're carrying about 990 gigs of traffic a day across both the operators at just Mumbai Central Station, including VoLTE traffic, but we were also able to increase the traffic capacity of the surrounding sites and the KPIs of the surrounding sites pretty substantially as well. So you saw throughputs in surrounding sites go up by as much as 25%. You saw payloads go up by as much as 20%, just because of the fact that we were able to deliver this density solution at that particular location. And a lot more today in the afternoon if you guys come to the breakout session.
Thanks, Kunal. So we have time for a couple of questions. And I think as we were looking at the global tracker, we